So in one of the videos I talked about continuous and discrete domains. Okay, so basically domain types. Okay, so domain types. Okay, there are two different types of domains that we use to create functions. Okay, and these domain types are basically the inputs for functions. Okay, and so there are two types. There is a continuous function, which is what most students learn about in high school. Then there are other types of functions. There are discrete functions. So let's look at what a continuous function looks like. A continuous function, basically, and I'll use a graphical representation to show this. Basically, you've got your x-axis, your y-axis, and you've got a list of values. You've got your domain, okay, which I'll use this, the domain of x, and you've got your range, the range of y, okay, or range of f of x. So basically what a continuous function looks like is you have a function that doesn't stop. Okay, it continues no matter what you do. It's going to have a whole bunch of curves, and no matter what, you can plug in values in between and plug in decimals and all that jazz. Okay, so let's say right here this value was 1, and of course that's 0, 0, right? So at 0, 0, you're going to get some point at 0b. Now, between 0 and 1, right here along this length, you have a decimal, right? You've got the 0 value, you've got 1 value, but you got all of these other values that can be in between. So like, let's say I've got 0.5, right? 0.5 would be right here. 3/4, 0.75, would be right here. So if you look at it, I can plug in all of these tiny little decimal points in between that occur on the function between whole numbers and values. Okay? So the continuous function use inputs, so x's are elements of all real numbers, and also x's can be like a fraction, x's can be a integer, x's can be a whole natural number, okay, and x's can be irrational. We've got all of these are rational, which is basically this one. X can also be irrational, which we use this little symbol tilde for not. Okay, and basically this is an integer. This is a natural number, like counting number 0, 1, 2, 3. This is a fraction. Fractions are rationals. Okay, and fractions are rational numbers. And then you've got not rational, which are like pi, e, square root of 3, square root of 2, phi, omega. Numbers that just repeat and don't terminate and don't have some coherency in terms of pattern. So that's what a continuous function is. Discrete functions, on the other hand, are not continuous. They are discrete, meaning they change from one value to the next. So like, let's say here I've got x value 1. Apologize for all the grunting. I'm trying to clear my throat. X value of 2, x value of 3, x value of 4, and for kicks and giggles, let's do x value negative 50. Okay? No matter what, the domain for x is just negative 50, 1, 2, 3, and 4. I cannot plug in any other numbers in between. Basically, what I get is, along with that, the range of x is going to be from, let's say negative 50 gives me a value of 1. I'm going to get 3 at 1, 2 at 2, 4 at 3, and then 0 at 4. Okay, so if you look very closely, the range, let's do 1, 2, 3, 4, and 0. Okay, basically, negative 50, I get 1. At 1, I get 3. Oh, yeah, 1, I get 3 right here. I can't do that one. Oops. No. I don't like that. I don't know why I did that. There we go. Okay. Okay. Go back to that. I don't. And then, so 1 at 3. And that value right there is 3. So that point is 1, 3. And then when the value is 2, I get 2. So 2, 2. And then 3, 4. So 3 bounces back to 4. And then 4, 0. That's a function. And it's just a set of points. And so basically we can represent functions as a set of points. And it's still a function. This is what we call a discrete function. And the discrete function, x can only have certain values. And discrete functions are basically a function of points. Good way to think about it. It's a function where your graphical representation is a set of points. It's not connected with a line. It's not connected with a pattern. There are patterns that you can use, but there's no definite pattern. No matter what, at negative 50, y value is going to take on 1. No matter what, at 1, y value is going to take 3. No matter what the value is at 2, it's going to take on 2. No matter what it is at 3, it's going to be 4, 4, 0. And there are no other spots that I can plug in between. Like negative 25 does not exist on this function. 0 does not exist on this function. 1.5 cannot exist on this function. 2.5 cannot exist on this function. 3.5 cannot exist on this function. And so you get two different very distinct types. Basically in algebra, we use a lot of continuous functions. In statistics, we use a lot of discrete functions. We actually use a mixture of both, but the common one that most statistics teachers forget to talk about are the discrete functions. And basically, when you get to Bernoulli distributions and certain types of statistical distributions based off the standard deviation and the crit values and all that jazz that you'll learn about, they take on discrete values, and they are considered a discrete function. So I hope this helps in understanding the different types of domains that exist within functions.